All right, welcome to this module on local area networks. My name is David Zemny and I'll be your instructor over this module. You got any questions? Well, if you do, use the question and comment box on gogo.com. Let's get started. In this module, we're going to talk about the standardized processes for local area networks, and that's the Institute of Electrical and Electronics Engineers IEEE 802 overview. We'll take a look at all of the efforts that have been expended on the part of developing local area network and some really big local area network type of protocols. And by that I mean some that actually go beyond the original scope of local area networking. So it'll be interesting to see just the massive work that's taken place in developing local area networks. We've talked about data link layer addressing in previous modules. Well, here we'll take a look at the exact addressing scheme as proposed by the IEEE and the LAN addressing methods, the media access control access addresses that we've talked about earlier. We'll take a look at the details of frames that are found in the LANs as defined by the IEEE, and we'll look at a couple of the exact protocols, the specific protocols for local area networking, and that is the IEEE 802.3 Ethernet protocol. We'll take a look at the topologies associated with the LANs, especially those topologies associated with Ethernet, and take a look at switching versus shared concepts in the deployment of Ethernet, and we'll see why we have evolved to switched Ethernet. And one other IEEE protocol of importance to us is a wireless LAN protocol, and that's 802.11. There are obviously a lot of different numbers that haven't been used, and we'll talk about a few of those as well to give you a feel for the vast array of efforts that has been expended on the part of the IEEE in developing standards for LAN communications. So we'll wrap up with the LAN basics in the overall module. Okay. An idea of a protocol is to make things, I guess, easier. So within the 802 suite of standards, there are some common portions of the protocol. The idea is keep as much the same as you can and change only a limited portion of the protocol whenever a feature requires that a change to be made. So in the IEEE standards so far, 802.1 is the common architecture and the interfacing with higher layers. 802.2, here's the logical link control features. We'll talk a little bit more detail about that. And then at the 802.3, we will see the inclusion here of a specific media access control method or group of methods for something called Ethernet. As these architectures and topologies were being explored and developed, some existed for a brief period of time or a reasonable period of time, and then ultimately were considered not particularly useful for more modern networking techniques. An example there was 802.4 token bus. This was used successfully in the manufacturing arena for a number of years, and we found that the same processes can very efficiently be handled with Ethernet and switched Ethernet environments today, so there's no need to support two different protocols. A competitor early in the development of LANs to Ethernet was Token Ring, and the Token Ring protocol was originally introduced by IBM, and the Token Ring architecture would perform much better under loading than did Ethernet. So it was amazing that over the years, the survivor of all of these protocols has been Token Ring. Let's talk about a few more. 802.6, a metropolitan area network protocol. 802.7, broadband LAN using coax, done away with. 802.8, the fiber optic technical advisory group disbanded. 802.9 disbanded. 802.10 disbanded. 802.11, well, alive and well, and we'll talk about that in more detail as we go through the modules. Some others that we might take a look at. As Ethernet was migrating from 10 megabit rates to 100 megabit rates, some proprietary work done by Hewlett-Packard introduced 802.12 demand priority queuing. It came under the name of 100 VG Anylan, and this made an attempt to encroach on the territory of 802.3, but didn't stay around for very long. 802.13 was considered to be unlucky and has never been assigned. 802.14 deal with cable modems, no longer in use. 802.15 personal area networks. 802.16 is alive and well, and we see that in 802.16 and .16e for WiMAX and mobile WiMAX. So here's where we're getting into the area. Is this really a local area network protocol? And the answer is probably not. 802.17 resilient packet ring. All of these are IEEE 802 standards. Continuing on with the Radio Regulatory Technical Advisory Group, 802.19, 802.20, mobile broadband wireless access, is also having ongoing efforts being expended. So 802.21 and .22, this kind of rounds out the features here. So of the protocols we've talked about, if you can mentally envision these, 802.3 is live and well and constitutes almost all of the wired LAN activity worldwide. 802.11 is alive and well and represents most of the wireless LAN access worldwide. 802.16 and 802.20 represent some, metropolitan area to wide area network type access methods for high-speed broadband wireless. And these are being developed. Okay. Well, what were local area networks? The idea behind a local area network was an inexpensive way to provide interconnection for all my computing devices and allow them to share printers, file servers, and other network resources. We've got to keep it simple. We want it to be plug and play, and over the years, that's exactly what the LANs have become. True, just network commodities. You buy the stuff, you plug it in, turn it on, and it works. So we should take our hats off to the hardware designers and the developers, the drivers, and so forth that have made this hardware so reliable and so resilient. And can we get the bandwidth? Well, when we started out, 1 megabit was the goal, but we know now that even within our LAN backbones and Ethernet, we're at 10 gigabit rates, 100 gigabit Ethernet's being investigated. So the answer is yes, we have far exceeded the minimum requirements here of 1 megabit rates. And for that matter, most of our applications would not perform extremely well, except maybe something like email on a very low speed. So, an advantage here of a local area network is its limited size, but we would want to make sure that as our business grew, that we could scale the local area network architecture to support a larger number of users in a larger number of buildings or office spaces. So, and this wasn't true of all of the architecture. So this is a feature that we need to look to whenever we expand or investigate a new protocol, is can it scale to a larger size efficiently? You know, we can always make it bigger, but when we say that it's scalable, it has to be able to perform adequately in its larger environment, just as it did in the smaller environment. Okay. So, as we saw earlier, there's some common parts to the 802 architecture, and that is the 802.1 and 802.2. So 802.1 remembers and relates 802 LANs to the higher level protocols and describes aspects of addressing, bridging concepts, and management issues. And you can see that those issues would be ones that are indigenous to all of the LANs that we would be working with, whether it would be Ethernet or Wi-Fi. Some other things to deal with. The OSI data link layer, though, needed to be divided and you'll see that it makes some sense, needed to be divided into some additional layers. The logical link control sublayer functions and the media access control sublayer functions. 802.2, the LLC logical link control sublayer, helped us deal with the issues of providing link frame transport, point-to-point, or multicast and broadcast type service. And then you can see that this too is something that could be associated with any of the different types of LANs that would exist at a lower layer, namely the media access control layer. The idea here of the 802.2 is this hides the differences of the lower layers from the network functions. And if you think about it, they don't need to be visible to the network layer operation. So let's take a look at the overall group of layers and sublayers here. The 802 committee of the IEEE provides the international standards for these LANs. All LANs provide frame forwarding. Remember, the payload of a LAN frame is typically an IP packet. And the LANs here are operating at layer 2 and layer 1. So we're seeing here from the data link layer and physical layer, layers 2 and layer 1 is where the functionality occurs. The initial work produced a LAN protocol model that takes the layered concept one step further. The data link layer is divided into 3 sublayers: the logical link control, media access control, and the physical layer. So LANs today use this particular model, and this is the structure that is built in hardware and firmware. So here's communications over a LAN, the LAN cloud. I start with my upper layers in the TCP/IP model, the application support running TCP or UDP, and processed into a packet running IP, and then the sublayers associated with a 802 type of LAN. The network operating system handles the upper layer activity, and the drivers and network interface cards handle the lower layer activity. 802.1 and 2. The task groups noted by the suffix. The 802 is the overall suite of protocols for all of the different LAN types. We use a suffix notation to give the standard mechanisms and services for each of the sublayer. And here's what we have for some of the predominant sublayer associated with local area networks. Notice that the predominant sublayer is the media access control. If we have different topologies, different architectures, then it is logical to assume that there will be different mechanisms used to gain access to the channel so that communications can take place. And we'll go into the details here for 802.3 and 802.11. Remember, we included the 802.5 token ring and the 100 VG any LAN here, just to show that, yes, there were alternative choices available, but cost and performance factors over the years have proved that 802.3 and 802.11 are the ones that were resilient enough to weather the storm. Okay, let's take a look at the frame structure associated with a 802.x type of LAN. The hardware addresses appear in the frame header. Notice, though, that on the picture here we have a preamble and start delimiter. This is a wake-up sequence. Remember, the LAN is an asynchronous operation, and that means when no data is to be sent, there's nothing on the wire. So the idea of the preamble and the start delimiter is to wake up the receive electronics as quickly as possible and have it ready, have it fully able to read the destination addresses as the frame arrives. The destination addresses, remember, consist of the 48-bit fields broken into two 24-bit sequences representing a manufacturer ID, and this is assigned to the manufacturer by the IEEE. And you can see a flag here, and if you have a chance, go out to a website and look up a list of different MAC addresses, and you'll see what manufacturers they're actually associated with. And then you can take a look at the network interface cards, or go to ipconfig in your laptop, take a look at the hardware address, and you can begin to figure out who made the chipset. And then the remaining 24 bits is assigned by the manufacturer and represents a serial number. So each address in this form is said to be globally unique. Well, another name for these hardware addresses was data link addresses, but one that we often call, or just hardware addresses, are called MAC, Media Access Control Addresses. And remember that they're 6 bytes, 48 bits, and assigned to the network interface card by the manufacturer and are unchanged for the life of the device. I think I mentioned in earlier generation devices that these addresses were changeable, but we learned through experience that it's not a wise thing to do. Let the address be permanently part of the network interface card. Okay, what about LAN frames? We talk about a combination here of the MAC and logical link control sublayers define the overall LAN frame. So without looking at the strings of ones and zeros here, we have a preamble followed by the destination and source 48-bit fields, and we have two octets here, 1 octet each for a MAC control field and a logical link control header, a payload that is variable from a small amount up to a large amount, and we'll show what those limitations are here in a minute, followed by a 32-bit frame check sequence. The figure shows the overall concept of what this frame is. We'll continue discussions in an upcoming module on some more details of Ethernet. But do you have any questions? And if you do, remember, use the question comment box on the GoGo.com page. Thanks for joining us. See you soon.